Recently, on April 19, 2025, a video surfaced on the social media platform X, showcasing a stark demonstration of modern warfare's evolution. The footage depicted Russian fiber-optic-controlled first-person view (FPV) drones destroying a French-supplied Caesar 155mm self-propelled howitzer operated by Ukrainian forces. A subsequent strike targeted an ATS-59 artillery tractor attempting to evacuate the damaged gun. While the exact date of the incident remains unclear, its publication underscores a pivotal shift in the Russia-Ukraine conflict, where low-cost, highly maneuverable drones are challenging even the most advanced Western-supplied weaponry. This event, far from an isolated skirmish, highlights the growing dominance of drone technology on the battlefield and raises critical questions about the future of artillery warfare. The Caesar, or Camion équipé d'un système d'artillerie, is a cornerstone of modern artillery systems, developed by the French defense contractor Nexter, now KNDS France. Mounted on a 6x6 Renault Sherpa 5-truck chassis for the French Army, with some export models using an 8x8 configuration, the Caesar combines mobility, precision, and rapid deployment. Weighing approximately 18 tons, it is among the lightest 155mm self-propelled guns in the world, measuring 10 meters in length and 2.55 meters in width. Its .52 caliber barrel can fire NATO standard shells, including extended range, full-bore ERFB ammunition with base bleed, reaching targets over 40 kilometers away, or rocket-assisted and smart munitions extending to 55 kilometers. The system's onboard ammunition capacity is 18 rounds, with a firing rate of 6 rounds per minute. Equipped with an inertial navigation system and a ballistic computer, the Caesar integrates data from surveillance drones and forward observers, enabling automated targeting and fire adjustment. Its shoot-and-scoop capability allows it to fire a volley and relocate in under a minute, minimizing exposure to counter-battery fire. Since its introduction to Ukraine in May 2022, with France delivering 30 units and Denmark contributing 19, the Caesar has been lauded for its effectiveness, with Ukrainian gunners mastering its operation in days. However, its light armor, designed to prioritize mobility, leaves it vulnerable to direct attacks, a weakness exploited in the recent incident. The Russian FPV drones responsible for the strike represent a technological leap that has reshaped the conflict. Unlike traditional drones reliant on radio frequencies, these FPV drones are controlled via fiber-optic cables, rendering them immune to electronic warfare. Jamming, a tactic both sides have heavily employed. Fiber-optic cables provide a secure, high-bandwidth connection, delivering real-time, high-resolution video feeds to operators, often at 50 frames per second, enabling precise targeting. The cables spooled out during flight can extend up to 20 kilometers, though they add weight, approximately 2.3 kilograms, for a 10-kilometer spool, and limit maneuverability. Despite these constraints, their stealth and reliability make them formidable. Russian sources such as the Telegram channel Russian Weapons have reported their use in targeting high-value assets, including Western-supplied tanks like the Leopard 2A6 and M1 Abrams. The drone's low cost, often under $2,000 per unit, contrasts sharply with Caesar's estimated $4 million price tag, amplifying their strategic impact. The ATS-59G tractor, a Soviet-era vehicle used in the evacuation attempt, underscores the logistical challenges Ukrainian forces face. Introduced in the 1950s, the ATS-59 is a tracked artillery tractor, designed to tow heavy guns and transport crews. With a top speed of 40 km per hour and minimal armor, it is ill-suited for rapid retreats under drone surveillance. Its use in this incident likely reflects Ukraine's reliance on older equipment for support roles, a necessity driven by the intense attrition of modern assets. The tractor's destruction highlights how drones not only target primary weapons but also disrupt recovery efforts, compounding losses. This incident reflects broader tactical shifts in the Russia-Ukraine war, now in its third year. Russian forces have increasingly integrated FPV drones into their operations, using them to strike concealed targets and disrupt logistics. The destruction of the Caesar and ATS-59 is a microcosm of a broader transformation in warfare, where affordability and adaptability often trump traditional metrics of military power. The Russia-Ukraine conflict has demonstrated that a $2,000 drone can neutralize a $4 million artillery system, upending cost-benefit calculations for defense planners. This dynamic challenges not only Ukraine's ability to sustain its Western-supplied arsenal, but also the strategic assumptions of NATO allies. France, for instance, has committed to increasing Caesar production, with Nexter planning to deliver 109 MKII variants to the French army by 2030. Yet without robust anti-drone defenses, these systems risk becoming liabilities in future conflicts. From a broader perspective, this incident underscores the need for a doctrinal shift in how militaries approach artillery and battlefield logistics. Integrating drones with artificial intelligence, enhancing real-time surveillance, and developing resilient supply chains will be critical for maintaining operational effectiveness. The war in Ukraine has exposed the fragility of even the most advanced systems when faced with innovative, asymmetric threats. For the United States and its allies, the lesson is clear: adaptation must outpace complacency. As nations watch this conflict unfold, the question remains whether they can innovate quickly enough to counter the next generation of battlefield threats. Will the West's technological edge endure? Or will the drone-driven future favor those who master affordability and scale?